All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is net ionic equations. You're not going to need a calculator or a periodic table for this one, but you will need a solubility chart. So if you don't have that handy, go ahead and pause the video and we'll get started. So here we go. It says, if necessary, first complete and balance the formula equation. Remember to consider whether the products are soluble or insoluble in water. Then write the ionic equation, and finally write the net ionic equation and identify the spectator ions. If no precipitate will form, write NR for no reaction. Okay, so a lot to think about on this one, so let's get started. Here we go. Number one says we have calcium chloride, aqueous, plus 2 moles of silver nitrate, also aqueous, yielding calcium nitrate aqueous and 2 moles of silver chloride solid. So a couple of different things. First of all, this is a double replacement reaction, so you should be able to recognize that. The second thing is that it is balanced for us. It's a 1 to 2 to 1 to 2 mole to mole to mole relationship. And lastly, there is a solid formed in the product, so that means the reaction is going to go and we can proceed. So how do we write an ionic equation? Well, we look to see, first of all, what is aqueous. Aqueous means that when you place that species into water, it's going to dissociate into its component ions. So we'll start with calcium chloride. We see that it's aqueous, and by the way, both species on the left-hand side of the arrow are going to be aqueous, so don't worry about that. You're going to have to break them down. So calcium chloride becomes calcium ion. It's in the second column, so it's Ca2 plus, aqueous. Plus, now watch this. There's a 2 subscript after the chlorine. That means that 2 moles of chloride ions are formed. So we say plus 2Cl minus, and again, that is aqueous, right? So now I've broken down I dissociated the CaCl2, and now I'm going to go to the silver nitrate. Notice that there is a 2 in front of the silver nitrate. That coefficient applies both to the silver and the nitrate ions. So we have 2 moles of silver ions, aqueous, plus 2 moles of nitrate ions, also aqueous, and we're finished with the left side of this equation. Let's move over to the right-hand side. Well, we see that calcium nitrate is formed, but it is aqueous. That means it's going to break down in a water solution or a solution. So calcium becomes Ca2 plus, that's aqueous, and nitrate has a 2 after it, so that's 2 moles of nitrate ions, also aqueous. Plus, notice silver chloride is a solid. You can verify that using your solubility chart, and there's a 2 in front of it, so we have 2 moles of silver chloride. That's a solid. Now let's talk a little bit about spectator ions. A spectator ion is one that that is present on the left-hand side and the right side of the reaction, but really doesn't take part in the actual reaction. So in this case, that would be calcium ion. You can tell because calcium ion is present before and after the reaction has occurred, and nitrate as well. 2 moles of nitrate on the left, 2 moles of nitrate on the right. So we know that calcium ions and nitrate ions are simply spectators. They're present at the beginning and the end, but really don't participate in the reaction itself. So after the spectators have been removed, what's left? Well, that's going to be the net ionic equation. We've got 2Cl minus, aqueous, plus 2Ag plus, aqueous, forms 2AgCl solid. So that is the net ionic equation. So we've done everything that we've been asked. We'll move on to number 2. Number 2 says we've got magnesium chloride, aqueous, plus 2 moles of sodium hydroxide, also aqueous. Remember, they'll always be aqueous on the left-hand side. Yields magnesium hydroxide, that's a solid, and 2 NaCl, that's aqueous. It's balanced for us. We see that there's a solid on the right-hand side, so we're ready to go. Let's look for the aqueous species on the left and the right. Let's start with the left. We have magnesium chloride. Magnesium chloride is going to break down into Mg2 plus, aqueous, plus, notice there's a 2 subscript after the chlorine, so 2 chloride ions, that's Cl minus 1. That's also aqueous. So we're completed. We've done the MgCl2. Now let's look at the NaOH. So we have 2 Na plus, that's aqueous, plus 2 OH minus, also aqueous, and we're finished with the left side of this equation. Let's go to the right-hand side. Magnesium hydroxide is a solid. You can verify that using your solubility chart. That means you don't touch it. You don't break it apart. That's what solid means. It does not dissociate in a liquid like water. So leave it alone. But the sodium chloride does. It is aqueous. So 2 moles of sodium ions. There's a 2 plus right there. 2 Na plus right there. That's aqueous. Plus 2 moles of chloride ions. That's also aqueous. And now let's look for spectator ions. What is present both on the left and the right? Well, notice I've got 2 moles of chloride ions on the left, and I've got 2 moles of chloride ions on the right. I've got 2 moles of sodium ions on the left, and I've got 2 moles of sodium ions on the right. Those then are my spectator ions. What's left? Well, we've got magnesium ions, Mg2+, that's aqueous, and 2 moles of hydroxide ions, also aqueous, yielding magnesium hydroxide, and that is a solid. So that's my net ionic equation. What you see in green is the net ionic equation, and I'm done with number 2. All right, let's go to the third problem. Number 3 says this. Now this one, notice we have to balance first of all, and it's 2, 3, 1, 6 balances this reaction. So verify that. 2, 3, 1, 6 is the balanced reaction. Notice also that the aluminum carbonate, Al2CO33, is a solid, and sodium chloride is aqueous. So we're going to get a reaction because of the solid. So let's start to break down the aqueous species on the left-hand side. AlCl3 is aqueous. Notice there's a 2 that applies both to the Al and the Cl3. That gives us 2 Al3 plus ions on the left, plus, now watch this, 2 times 3, coefficient of 2, subscript of 3, multiply those together, is a 6. So 6 Cl minus aqueous plus 3 times 2, that's 6 Na plus aqueous plus 3 carbonates, 3 CO3 2 minus aqueous on the left-hand side. So we've absolutely broken down everything on the left-hand side. Let's go to the right-hand side. Remember that the aluminum carbonate, the Al2CO33, doesn't break down at all. It's a solid. Leave it alone. Plus 6 moles of Na plus ions, so 6 Na plus aqueous, plus the 6 applies to both to the sodium and the chloride, so 6 moles of chloride ions, and we're done with the ionic equation. Let's identify spectator ions now. Things that are common on the left and the right don't participate in the reaction. Well, let's see. We've got 6 moles of chloride ions, 6 moles of chloride ions, 6 moles of sodium ions, 6 moles of sodium ions, and I think that's all. So those are the spectator ions, chloride ions, and sodium. What's left? Well, we've got 2 moles of aluminum 3+, that's aqueous, and 3 moles of CO3 2-, also aqueous. So that takes care of the left-hand side. On the right-hand side, all we've got left is aluminum carbonate, that's Al2CO3 3, that's a solid, and we're done with number 3. Let's go on to number 4. Number 4 says we've got lead nitrate, aqueous, plus magnesium iodide, aqueous. Remember, they'll always be aqueous on the left-hand side, yields lead iodide and magnesium nitrate. We have to balance it. Fortunately, it's easy to balance. 1, 1, 1, 1 balances it. Lead iodide, I should say lead 2 iodide, is a solid, right? That means it's going to go. Magnesium nitrate is aqueous, so we can proceed. Let's break down the lead 2 nitrate. So we have Pb2 plus aqueous plus 2 moles of NO3 minus 1 aqueous. Why 2? Because there's a subscript of 2 after the nitrate. So now we've taken care of the lead 2 nitrate. Let's go to the magnesium iodide. We've got Mg2 plus, that's aqueous, plus there's a 2 subscript, so that's 2 moles of iodine on the right-hand side. That's also aqueous. Yields lead iodide, lead 2 iodide rather. Leave that alone. It's a solid. So we have lead 2 iodide is PbI2, that's S, plus Mg2 plus aqueous. There's a 2 plus is the charge on the magnesium, plus there's a 2 subscript after the nitrate, so that's 2NO3 minus 1. That's aqueous. Let's find the spectator ions. Well, let's see. We've got Mg2 plus on the left-hand side and Mg2 plus on the right-hand side. We've got NO3. We've got 2 NO3s on the left. We've got 2 NO3 minus 1s on the right. Those are my spectators. What's left? We've got lead plus 2 aqueous plus 2 I minus. That's aqueous. Yields PbI2. That's a solid. Lead 2 iodide is a solid. So that's our net ionic equation, and we're done then with number 4. Now let's take a look at number 5. Number 5 is interesting because of the fact that when we look at MgC2H3O2 in combination with CaBr2, when we cross the Mg with the Br and the Ca with the acetate, what we find is that neither one of the products is a solid. So if neither one of the products is a solid, that means we're not going to get a precipitate, and there's no reaction. We put NR, and we're done with it. There is no ionic equation. There is no net ionic equation. There are no spectator ions. In fact, you can just think of it as all of them are spectator ions, I guess. But the point is that there is not a reaction if there is no solid on the right-hand side, and we'd be done with number 5. Let's look at number 6. We're going to have to balance this when it balances as 1, 1, 3, 1. And then what we're going to do is we're going to look for a solid on the right-hand side. Aluminum phosphate is a solid. That means it's going to go, right? It's going to make it. So now let's start breaking things on the left-hand side down. We have K+. There's 3 of them because of that subscript of 3. So 3K+, that's aqueous, plus phosphate is PO4 3-, also aqueous, plus aluminum, that's 3+, that's aqueous, plus 3 chloride ions. Notice that 3 on the bottom yields 3 ions of chlorine. So, or chloride ions, I should say. So 3 chloride ions on the left-hand side. That takes care of our left-hand side. Let's look to the right-hand side. So we have 3K+, that's aqueous, plus 3Cl-, also aqueous. That 3 applies both to the K+ and the Cl-, plus we have AlPO4, aluminum phosphate, right? Aluminum phosphate. That's a solid, so we'll leave it alone. Let's look to see what the spectator ions are. Well, we've got 3K+ on the left, we've got 3K+ on the right. We've got 3 Cl- on the left, we've got 3 Cl- on the right. So now what's left? The net ionic equation is what is remaining. PO4 3- is aqueous, that's on the left, plus aluminum 3+, also aqueous, that's on the left, yields AlPO4, that's a solid, and that is our net ionic equation. We're done with number 6, and we'll go to the final question. Number 7, we've got sodium sulfide plus silver nitrate yields sodium nitrate and silver sulfide. First, let's balance. 1 to 2 to 2 to 1 balances this reaction. And when we look at our solubility chart, we see that silver sulfide is a solid. So we've got a reaction. Let's start breaking things down on the left-hand side. The sodium sulfide, we have 2 subscripts, so we have 2 Na+, that's aqueous, plus S2-, also aqueous. So that takes care of the sodium sulfide. Now let's take care of the silver nitrate. We have 2 silver, that's +1, right? I know it's +1 because of the fact that nitrate is -1. It's a 1-to-1 ratio, so we have 2 Ag plus aqueous plus 2 NO3 -1, also aqueous. I'm done with the left-hand side. Let's go to the right-hand side now. We've got 2 Na plus, that's aqueous, plus 2 NO3-, also aqueous. Leave the silver sulfide alone. It's a solid. Ag2S is a solid. Just leave it alone. Let's look for spectator ions. We've got Na+. Actually, we've got 2 Na+ on the left. So we've got 2 Na+ on the right. We've got, let's see, 2 NO3- on the left and 2 NO3- on the right. And so we'll ask ourselves what is left. We've got S2- aqueous plus 2 Ag plus aqueous on the left-hand side. What's left on the right-hand side? Ag2S, the solid. That'll do it for the last one. We're done with net ionic equations. Thanks. I'll see you in the next one. Bye-bye.